In our previous video, we looked at multiplying rational expressions, and then simplifying and stating any restrictions. We're going to do the same thing in this video, but instead of multiplying, we're going to divide. A quick refresher, if we were to divide two fractions, for example, 1/4 divided by 3/5, recall that that is the same thing as multiplying by the reciprocal. So 1/4 divided by 3/5 would be the same thing as 1/4 times 5/3, and then we would multiply the numerators, multiply the denominators, and we would end up with 5/12. We're going to use that same logic in order to divide these rational expressions. But before we start dividing, realize that we should look for non-permissible values, since these expressions have been fully factored. And in this case, we cannot have b equal to 0, because if we did, we would be dividing by 0 in this first fraction. And we also cannot have d equal to 0, because if we did, we would be dividing by 0 in the second fraction. Okay, let's multiply by the reciprocals now. So a over b is divided by c over d, so that would be the same thing as multiplying by d over c. But observe, before I go any further, that in doing so, we have d over c. Well, this is actually going to introduce a new non-permissible value. C cannot be equal to 0, because if we had c equal to 0, then we would end up dividing by 0. All right, what is our final expression? So we're going to multiply these numerators. We'll have AD. We're going to multiply the denominators, so BC. What are all of the restrictions? Well, we do have 3 restrictions now. B cannot be equal to 0. C cannot be equal to 0. And d cannot be equal to 0. So note that even though d is in the numerator of this expression, it is a restriction, because in our original expression, it was in the denominator of the second fraction. So you have to be quite cautious when you are dividing by rational expressions, that what's going to happen is both the numerator and the denominator of the expression that you are dividing are going to produce restrictions. Whereas in this original fraction of a over b, the denominator would produce restrictions. Note that b, c, and d all end up being restrictions. So that's an extra point that you have to be cautious of when you are dividing rational expressions. That because dividing is the same thing as multiplying by the reciprocal, both the denominator and the numerator are going to produce these restrictions. Okay, let's look at a more complex problem so we can see this in action. So we want to simplify this rational expression and state any restrictions. So we're going to want to begin by factoring each of these numerators and denominators as much as we possibly can. So x squared subtract 1, that's the difference of squares. That's going to leave us with x plus 1 times x minus 1. In our denominator, x squared subtract 3x. So this has a factor of x in common, and if I were to factor that out, I would be left with x minus 3. So there's our first fraction, and we factored the numerator and denominator. So now let's move on to our second fraction. Looking at the numerator, we have x squared minus 5x plus 4. So this is going to factor into x minus 1 times x minus 4. And now let's look at the denominator of this second fraction. And this is going to factor into x minus 3 times x plus 2. All right, before we go any further, let's look at any non-permissible values. So we have x cannot be equal to 0, x cannot be equal to 3, x cannot be equal to 3 again, x cannot be equal to -2. I listed it twice here. that x cannot be equal to 3. It would be fine if you just listed it once since it's the same factor repeated. Now we're going to reciprocate the second fraction. So we will have x plus 1 times x minus 1 divided by x times x minus 3. And we're going to multiply that by the reciprocal of the second fraction. So we will have x minus 3 times x plus 2. And all of that is divided by x minus 1 times x minus 4. And note the introduction now of two additional non-permissible values. X cannot be equal to 1. X cannot be equal to 4. So finally, it's time to divide any factors which are in common in the numerator and denominator. So x minus 3 divided by x minus 3 is equal to 1, provided this restriction. X cannot be equal to 3. We have x minus 1 divided by x minus 1 is equal to 1, provided the restriction, x cannot be equal to 1. And it doesn't look like we have any other factors that are in common. So we end up with x plus 1 times x plus 2 divided by x times x minus 4 with all of these restrictions that we have previously identified. So starting with the least value, x cannot be equal to -2, 0, 1, 3, or 4. So as I've mentioned before, note that when we get to our simplified value, only some of these are observable. But based on our original problem, all of them are restrictions. Now, based on the previous problem, perhaps you may have observed that at this step, we could have identified all of these restrictions and not broken it up into multiple parts. And there's absolutely nothing wrong with doing it. In some ways, it actually might be preferable. So if we're dividing by a rational expression, you have to consider all of these factors as non-permissible values. Whereas if we just have a fraction or a fraction that is being multiplied, we only need to consider the ones that are in the denominator as non-permissible values. Either way, however, you will get to the correct non-permissible values in the end. One final thing I would like to point out is this question asked for a simplified rational expression, and I gave a simplified and factored rational expression. It would also be fine to list your final rational expression in this form, because this has been fully simplified. Of course, we would have to list all of the restrictions. Your teacher may force you to do one form over the other, and there are of course benefits to leaving it in factored form. That being said, I suspect in most cases this is the version that your teachers will likely be looking for, where we have reduced every factor that is in common in the numerator and denominator, and then we have one final simplified expression where both the numerator and denominator have been expanded out. But again, that may depend on your teacher's preference. Okay, so now we have looked at multiplying and dividing rational expressions and looking for their restrictions or their non-permissible values.